Ideal gas law problem. Couple things. The amount of our gas is given in mass, so we have to determine the number of moles of this gas from mass divided by formula weight. Also, our temperature is given to us here in Celsius. Anytime we use the ideal gas law, temperature must be expressed in Kelvin, so we'll have to convert Celsius to Kelvin. Alright, so we've done our conversion from Celsius to Kelvin, and we've determined our formula weight for Freon gas. We're given the formula, so we can easily calculate the formula weight. We're going to use the ideal gas law to calculate the volume in liters. So we start with the ideal gas law, and we're going to solve for volume. So to solve for volume, we multiply both sides of the equation by 1 over P. That causes P to cancel out here, and we're left with volume is equal to nRT over P. One way to solve this is to get a separate value for the number of moles of gas. I'm going to suggest a faster means that's going to serve you better in the future, is that you take this expression, mass divided by formula weight is equal to n, and substitute it in to this equation. This will make your calculations go faster. You don't need to spend the time writing out a separate value, and this is a more sophisticated means for solving the problem that will be valuable to you when you go on to Gen Chem. So this is how that would work. We have our mass, and we're going to divide by the formula weight, which we've already determined. And that causes units of grams to cancel out, and we're left with moles. Now we continue and input the rest of the numerical values. And here's our solution. Continuing on looking at units, we see moles cancel with moles, K with K, and atmospheres with atmospheres. The only unit that survives is liters, which is what we want because we want our volume in liters. We churn through the math. Now we look at sig figs. We see that we can justify 3 sig figs, so we have our final answer.